Derivatives of exponential functions. The number e remains of the utmost importance when dealing with derivatives for one crucial reason. The derivative of e to the x is e to the x itself. If u is a differentiable function of x, then we obtain the rule derivative of e to the u is equal to e to the u times du dx. The reason this is slightly different than this is because we know that the derivative of x is 1, so really there's a times 1 here. So in this case, u is not always x, so we have to write du dx, and in many cases compute du dx. So derivative of e to the u is e to the u times the derivative of the exponent. Regarding non-e base exponential functions, these can be related to e via the formula a to the power of x is equal to e to the power natural log of a to the x, which equals, using rules of logarithms, e to the power x natural log of a. So because x is in the exponent of the argument, that we can take the exponent and bring it out into the front of the logarithm. As such, the derivative of a to the u is equal to a to the power u times natural log of a times derivative of u. So essentially, the derivative of a to the u is itself times the natural log of the base times the derivative of the exponent. An example: differentiate y equals the quantity x cubed plus 4 to the power of x. So we'll start by taking the natural log of both sides of the equation. So natural log of y is equal to the natural log of x cubed plus 4 to the x. So how can we manipulate this? Well, we learned earlier that the natural log of a base to an exponent can be rewritten in the form, if we bring the exponent in front, we can rewrite it as x natural log x cubed plus 4. So now that we have it in a more appropriate form for differentiation, we can derive it by using the product rule. So we'll derive, so natural log of y, the derivative, 1 over y times y prime with respect to y. Using the product rule, we have derivative of x is 1 times natural log of x cubed plus 4 plus x times the derivative of natural log of x cubed plus 4, so 1 over the argument, x cubed plus 4, times the derivative of the argument, which is 3x squared. So 1 over y times y prime is equal to the natural log of x cubed plus 4 plus 3x cubed divided by x cubed plus 4. So to get y prime, which is our goal, we want to differentiate y, so we want to get y prime. We need to multiply both sides by y to cancel the y on the left side of the equation. So y prime is equal to the natural log of x cubed plus 4 plus 3x cubed divided by x cubed plus 4. This whole quantity times y. What is y? Well, we're given y up here. Y is simply x cubed plus 4 quantity to the power of x. Differentiate y equals 2e to the power 2x. So we know that the derivative, the constant just gets continued to multiply through. We know that the derivative of e to the x is itself times the derivative of the exponent, d dx of 2x. So y prime is equal to 2e to the 2x times 2. And just clean up notation by multiplying both 2's together. Derive y equals 3 to the power x squared plus 1. So using our rule here, we'll derive it. So y equals 3 to the quantity x squared plus 1. So using this first, y prime is therefore equal to this whole bit here, a to the u, times natural log of a, the base, times du dx. So d dx x squared plus 1. So y prime is equal to 3 to the power x squared plus 1 times natural log of 3 times 2x. And this is a much more useful result than trying to multiply out natural log of 3, and then multiplying it by the 2 and getting some strange decimal. This is a much more useful answer. Find the derivative of f of x is equal to x squared times e to the x minus x times e to the x. So f prime is equal to, so derivative of the first, derivative of 2x, derivative of the first times the second, plus the first times derivative of the second. Derivative of e to the x is simply e to the x. We applied the product rule here, and we're going to apply the product rule here again once more because of this product. Okay, so derivative of the first times the second plus the first times derivative of the second. F prime of x is equal to 2x e to the x plus x squared e to the x minus e to the x minus x e to the x. We can simplify this slightly. F prime of x, because these two guys are in the same format, just with the different coefficients. This has an essentially invisible coefficient of 1, so we get x e to the x plus x squared e to the x minus e to the x as our final result.